Hi everyone. So one of my subscribers just mailed me this problem and he wanted me to go around it and explain point method, how to apply point method to this problem. So yeah, I've made this problem and thank you for the appreciation or the mail. I really appreciate it. Yeah. So let's go around this problem and hopefully everyone who is watching this video will be able to get an understanding of how to apply point method to some type of difficult or you can assume some little complex problems, right? So let's dive at the problem. So first, always remember the basic rule. Okay, always like you should remember the basic rules. Go with the basic rules. So length is constant, right? Length of a string will always remain constant. Point number one. Point number two. If v increases length, v is positive. If v decreases length, v is negative. This is the point number two, right? Then what is the point number three? We mark all the points, right? Now let's go line by line. Okay. First, read the question once. So what is happening? Two blocks A and B. So A and B are two blocks shown in figure 1.154. Block A moves left with a velocity of 6 meter per second. Let's just mark it. 6 meter per second. Find velocity of block B, velocity of point P of the string, relative velocity of point M of the cable with respect to point P. Okay, these are the three questions asked. We have understood the problem. Now we understand. Okay, first thing, this is an NLM problem. First thing. Now let's try to attack it using the point method. So first, mark all the points. This is point 1, point 2, point of context, right? 3, point 4, point 5. Be very smart. What is happening here? This is not 0.6. This is where some of them can make a mistake. Look at the diagram carefully. This pulley is hinged to the wall, so this will not move. This pulley is hinged to the wall, so this will not move. This pulley is in the air, this will move, but this is not a string. Be very careful here. 5, 0.6, 0.7 and 0.8. So I have marked all the points in the pulley. Okay, 0.1 to 0.8 are 8 points. Now since I have a little feel for physics, let's feel it. So when the string is moving like this, most likely the pulley will go upwards, right? So I will assume this going with VB speed. Okay, now let's sum of all the velocities should be 0 because length of the string is constant, right? Distance is constant, so differentiation of distance is velocity. So velocity, sum of velocities has to be 0. Alright, so yeah, 1 will move like this. It will increase the length of the string between the point 1 and 2, right? So V1 is positive. 2 attached to the pulley is not moving, 0. 3 again 0. What is 4? 4 is moving with a velocity of VB, right? This is VB. Block B is moving with VB. And block B is attached, pulley is attached to the B with a rod type of thing. It is not a string, right? So this will be 0.4 is decreasing the length of the string, right? Between 2 and 4 it is decreasing the length. So it is minus V4. 0.5 again is going upwards. So it is decreasing the length between 5 and 6. So it is minus V5. 6 is 0. 7 is 0 attached to the pulley. 8 is again going upwards, decreasing the length, minus V8. Now V1 is how much? V1 is 6. And this is minus, if you think, see, 4 is moving with VB, 5 is moving upwards with VB, and 0.8 is also moving upwards by VB. This is the velocity of block B, right? So it is minus 3 times VB. So what is VB? VB is equal to 6 by 3 minus 3 by minus 6 actually, so which is 2 meters per second. So we are right in the assumption that VB is upwards because we got a positive sign here. So VB is going upwards. So first answer we have got, which is 2 meters upwards. So right, this matches the answer. Second one, velocity of point P of the string. Yes, so simple thing is length of the string is constant. Again we apply the same logic. So answer to 1 is sorted. Now we go to question number 2. Length of the string has to be constant. So 1 to P, the length has to be constant, right? Just think like one attachment to another attachment, the length has to be constant. right? So again we come here. What we'll do, we'll say V1 is increasing the length positive, V2 is 0, plus 3 is 0, plus 4. Plus 4 is what now? We know the answer, right? But let's see. Now let's write minus V4 over here. 5 is decreasing the length, minus V5. Point P. Point P, assume that point P is going downwards, right? I'm just assuming it because since this is going up, this has to come down. So I am writing it downwards. So downwards is what? Downwards between P5. Now just assume point P, right? Point P is decreasing the length, minus VP, right? It is downwards. I am assuming this is going downwards, VP, right? I am assuming it is going downwards, VP. So it is decreasing the length between P and 0.5. So yeah. So what is it? V1 is 6, right? 6, and this is what? Minus 2 minus VP is equal to 0. So what is happening here? 4 minus VP is equal to 0. So VP is equal to 4 meters. 4, no, sorry. This is what? 2. This is 6 minus 4, which is 2. VP is 2 meter per second downwards, which is another right answer. Yeah, 2 meter per second downwards. Hopefully you are able to get a feel, right? We are assuming VP downwards. VP is decreasing the length between P and 0.5, hence it is negative. We are able to get a positive answer, so we know that we have assumed the right VP. Now relative velocity between point M of the cable with respect to point B. Again, very simple answer. Like, this is nothing complex, okay? Now what do? We know here. Now again consider 1 to M point. 1 is V1, increasing the length, plus 2 is 0, plus 3 is 0. Now what is point VM? VM will go up. Going up will decrease the length. So it is minus VM. So what is VM? VM is equal to 2 meter per second. VM is 2 meter per second upwards, right? What is VP? VP is 2 meter per second downwards. VP is 2 meter per second downwards. So what is VMP? VMP is equal to VM minus VP. Now we are assuming, okay, that upward direction is positive and downward direction is negative. We have to assume. So positive y-axis I generally take is positive, negative y-axis generally take is negative. So that is VM. VM is what? 2 meter per second. This is minus of minus 2 because we are assuming down negative, which is 4 meter per second, which is positive direction. So we can say that upwards we have assumed positive. Sorry, our VM is what? VM is 2 meters per second. What is VP? VP is 2 meters per second. Sorry, our VM, V1 is 6. I'm sorry, here V1 is 6. So it has to be 6 meters per second is VM. So this will be 6. 6 plus 2 is 8. I do make silly mistake, guys. You have to excuse me for that. But yeah, hopefully this is clear, right? So V1 is 6. So VM is 6. So then I do VM minus VP. I assumed upwards should be positive, downwards should be negative. So VM will be positive, VP will be negative. It is 8 meters per second upwards, right? So yeah, matlab, sometimes you can be conceptually strong, but you make up errors while solving the problem. So please be careful. You have just got a live example right now here. So remember the values, enter the right values. Accuracy is very important in MCQs, right? So hopefully this gives you a feel around how to go around the problems. Again, I'll give a short revision. Length will always be constant. Mark all the points which are moving or point of contacts actually of the strings, not of the wedge. V1 increase, if velocity increases, length is positive. If velocity decreases length, velocity is negative. So velocity sign you have to take as per the length, right? If you assume the right velocity direction, you will get a positive answer. If you assume a wrong velocity direction, you will get a negative answer. Yeah, that's it, guys. 2 meters up, 2 meters down, and 8 meters up. We have got all the answers using the point method. Yeah. Bye, guys. Have a good day.